In this video, we're going to walk through how we can actually compare two population means using our paired differences method for a hypothesis test. And if we look at our breakdown here, it's the same breakdown that we've had in the past, where we have our three different types of hypothesis tests. We have the two one-tailed, so we have the less than one-tailed and the greater than one-tailed, then we have the two-tailed one in the middle, where we have our null hypothesis for all of them is mu d, or the mean of the difference, is equal to some d naught value. And then we have our less than, not equal to, and greater than alternative hypotheses. We can also, for our test statistic, we have the two different test statistics that we've had in the past. So we have z, where z is equal to our d bar minus d naught over sigma d over square root of nd, where we can also substitute in sd if we don't know what sigma is. And that will be for our large sample. So we have our large, where we use our z value. And for t, if we have a small value, so we do a small, we use our t statistic instead, where t is equal to our d bar minus d naught over sd divided by the square root of nd. And we have the same rejection regions as we've had in the past, where we have z is less than negative z alpha, or we can do t is less than negative t alpha for the small sample. When we're doing the one sampled on the left side, we have the absolute value of z is greater than z alpha over 2. The absolute value of t is greater than t of alpha over 2 for the small sample. When we're doing the two-tailed test, so mu d is not equal to d naught for our alternative. And then finally for our last one-tailed test, we have z is greater than z of alpha and t is greater than t of alpha over 2, depending on if we have a large or small sample test, for our one-sided test for mu d greater than d naught. And again, we're going to look at our t sub alpha and t sub alpha over 2. And we have, for either of those, we have nd minus 1 degrees of freedom. So if you're doing the small sample, you have the nd minus 1 degrees of freedom for our test there.